Hey, what's up, peeps? What in the heck are we going to do in this vid? We're going to explain how pH of aqueous solutions can be controlled with buffers. Big time here. We're going to calculate the pH changes of a buffer solution. It's a good time. Get some snacks. Get ready. All right, so remember that the purpose of a buffer is to resist large changes in pH. Remember that your buffer has weak acid and conjugate base components to make that happen. There's something there to neutralize the addition of any strong acid or strong base. However, adding a strong acid or strong base will cause slight changes in the pH, and we are going to think about how can we calculate the new pH after we've added some strong acid or strong base. Okay. So let's take a look at just a generalized equation for a buffer system. Remember that in a good buffer, you're going to have both weak acid and conjugate base present. If you have a strong acid added to your buffer system, recognize, here's my strong acid component. If I add this, there is something, my conjugate base, in the buffer system that is there, that's available to neutralize it. Now, there will be a slight change in pH, right? Because you are going to sacrifice some of your conjugate base. You're going to form some additional weak acid. So there will be a slight change in your pH. Now, not as much if you didn't have a buffered system, but definitely a change. Think about this in terms of toy soldier format. Got your buffer components, weak acid, conjugate base. Oh my goodness, we're being attacked. We're under attack by strong acid. Fear not, we've got some conjugate base there to protect the pH. It's going to neutralize that added strong acid and form additional weak acid molecules. Now, recognize in a buffered solution, you've got both weak acid and conjugate base available. It's like you're well protected on all sides. But in an unbuffered solution, it's like one of your flanks is left unprotected. Like if we just had the weak acid and no conjugate base, let's think about how the pH would be affected. So in the buffered solution, we've got some weak base there that will sacrifice its life in the name of pH. It'll get used up. Sure, it'll form some more weak acid, and therefore the hydronium ion concentration will increase. And so there is a slight change in pH. But think about how much more the pH would change in an unbuffered solution, right? There's no conjugate base there, so any added hydronium ion, any added strong acid is just gonna blow up the pH. The enemy is dropping in, and there's like no one there. We've like left the flank wide open. pH is gonna blow up. All right, similarly, let's think about what's gonna happen if you have a strong base added to your buffer system. Again, we have weak acid molecules in our buffer system that can neutralize that added invader, this time hydroxide, strong base. Think about what's going to happen. We'll use up some of our weak acid. It will form more of our conjugate base, and therefore, yes, the hydronium ion concentration will decrease slightly. So there will be a change in pH. Again, think about it in toy soldier format. Oh my goodness, we are under attack by strong base. Somebody save us. Again, we're going to try and protect the pH, protect the hydronium ion concentration. We've got some weak acid this time. It's going to step in, sacrifice its life to save that pH, create additional conjugate base in the process. Again, think about a buffered solution. We have both components. We're well protected on all sides. In an unbuffered system, we sort of left one of our flanks, unprotected. So in the buffered system, our conjugate base concentration is going to increase. We'll sacrifice some of our weak acid, so there will be a slight change in pH. In the unbuffered system, I've got just weak acid, no conjugate base. But when you're adding strong base, we've got some weak acid there that will neutralize it. We're going to create some conjugate base. So guess what? In a situation like this, you actually create a buffered solution because you are creating some conjugate base. So when that hydroxide attacks, that weak acid is there. Boom. Essentially, you're creating a buffer system. Okay, and lastly, I just want to remind you that it's important to recognize that because the concentration of weak acid to conjugate base is a ratio of concentration, it's really the amount in moles that's important. final volumes will cancel out, and so recognize that it's perfectly acceptable to use number of moles instead of concentrations. Okay, that does it for this vid. Check out some of those guided practice videos to think about how we're going to determine the changes in pH when it comes to buffer systems.